All right, let's jump into the addition rule for probability. Now, what I want to show you here is we have ourselves the formula. The probability of A or B, so A and B being two events, equals the probability of A plus the probability of B minus A and B. And remember, A and B, this is the overlap. That's why we have to subtract it. So let me show you in this contingency table of why this matters. So here's our problem down here. The probability of female or an independent if we choose a person at random. Now, here's our female line. Here's our independent line. Notice that this box is crossed twice. So if I find the probability of female, so we'll say that female is probability A, or event A, excuse me, independent is event B. So the probability of being female is 177 out of the total 376. I'm going to add the probability of independent, which is 181 over 376. But the problem is I've counted this 87 twice. I counted it in the female line. I've counted it in the independent line. So I have to subtract that overlap. The probability of female and independent is the overlap. And if I subtract it, then I've only counted it one time, because right now I've counted it twice. And if I take away one of them, I just have one. And that gives me the answer of 271 over 376 as the probability for independent or female. All right, let's jump into a new one. In a given dorm of 200 students, 47 students are in calculus, 65 are in biology, 78 are in history, 17 students are in biology and history, and 23 students are in both calculus and biology. What is the probability of choosing a student at random and they being in calculus or biology? Okay, now think about what you need to find here. We're looking for the probability of calculus or biology, which means we need to take the probability of calculus plus the probability of biology, and then subtract the probability of calculus and biology. So let's see what we have. Now, we know we have 200 students total. So the probability of calculus, let me change colors for fun. 47 students are in calculus, so 47 out of 200. How many students are in biology? 65. So 65 over 200. And we need to take away the students who are in both of these classes, right? Because we're counting them twice. If they're being counted as both calculus and biology, then we've counted them twice. So 23 students are in calculus and biology, so minus 23 over 200. And that gives us the probability of calculus or biology to be 135. That's not right. Time out. Okay, so when we add 47 plus 65 and then subtract 23, we are left with 89 over 200. So the probability of choosing a student at random who is in calculus or biology is 89 over 200. Now let's just do one that is strictly algebraic. We know the probability of A is 0.45, probability of B 0.37, probability A and B is 0.1. Okay, so, right, we're dealing with decimals to the 100th place. So I know that probability of A or B is probability of A plus the probability. If you are a visual learner, I recommend writing this out before doing every problem. It's going to help you remember the kind of the meshing of how it all goes. All right, so the probability of A plus the probability of B minus the probability of A and B, which gives us a nice answer of 6,500. So the probability of A or B. That's just doing the math and the formula that they give us. And I want to do one more where now we're trying to find the overlap. If we know the probability of A or B, given the probability of A and B, or excuse me, A and probability of B, we can find the overlap. Now, remember that this formula, A or B, probability of A plus the probability of B minus probability of A and B, has 4 unknown spots. As long as I know 3 of the 4, I can use, right, the solving of equations in order to find what I need. So I plug in the appropriate spots. I've got 5800ths, I've got 7200ths, I've got 1800ths, and my unknown value. So now it's a matter of solving this equation. And there's, a couple different steps, but if I combine these like terms, that's pretty light, but that's okay. I have 9/10 minus x. I'm going to go ahead and subtract 9/10 from both sides, and I get negative 32/100 is negative x. So if I multiply both sides by a -1, I will end up with a probability of 32/100. So the overlap, the probability of A and B is 32/100. Thanks all.